Section 3.3 should be basically a review for you. We talk about slope first, and the definition of slope is always going to be rise over run. So you think about it as the change in y over the change in x. Now, if we talk about what types of slope there are, we have 4 different ones that we need to be able to identify. One is a positive slope. As we go from, as x increases, as you go from left to right, it's going to be like an uphill. The negative slope, of course, is the reverse of that. As we go from left to right, it'll go down. A zero slope is like a floor, which should have no slope. And it's represented always by y is equal to a number. We call this a zero slope. And then when we have an undefined slope, well, it's straight up and down, and like a vertical line. And that is always going to be represented as x equals a number. Now, one of the things you're going to be expected to know, and you should already know from your past math studies, is that if you have 2 points, you can calculate the slope of a line. These 2 points are on the line, so I can calculate the slope. Now, I have to identify the point 1 and point 2. And it doesn't matter which we identify as which, and this is x of point 1, y of point 1, x of point 2, y of point 2. And that's just, it could be either way. Either point could be 1 or 2. And then the formula, of course, is m is equal to y of 2 minus y of 1 divided by x of point 2 minus x of point 1. Now, all that's saying is that we have to start with the same point for y and x and subtract the other point, y and x. So if you remember that, you're really going to be okay with slope. So let's do this one. So I'm going to say I want to draw this line, and I'm going to come up with my first point. Doesn't matter which one I use. I identified this one as the first point. I put the y in the top, and I put the x in the bottom of it. And then I'm going to say, okay, the other point. This is point 2. It really didn't matter. I sort of reversed it. But I have to put minus in because minus is in my formula. And then I'm going to put the x value in the denominator, and I'll put the y value in the numerator. Now, it's a negative y value, so I'm putting in parentheses because I have minus a negative here. Now, when I do this math, and like I said, it'll turn out either way, whichever point you use for 1 or 2, it doesn't matter. I'm going to have 5 plus 9, so I'm going to get up with a negative 4. And down here, I'm going to have 8 minus 2, which will be a positive 6. Let's fix this because, of course, this is plus 9, so that ended up being a positive 14. You saw that before I did, didn't you? And now all I have is 14 divided by 6, or 14 over 6, and I can reduce those two. I'm going to divide them both by 2, so I've got 7 over 3, and that is my slope. Let's do another one. Like I said, it doesn't matter which point is 1 and which point is 2. So I'm going to start with this one over here. I'm going to say I want to put the y value in the numerator, x value in the denominator. I'll put my subtraction down. The next point, I'll put the y value in the numerator, and I'll put the x value in the denominator. And check it out. I did y, x, just to check to make sure I've got it right. And now I'm going to say this is really negative 9 plus 9, which turns out to be 0. And this is really 0 plus 3, which is 3. Now, we can divide a 0 by a number, and it's okay. It turns out to be 0. So what this one is actually a horizontal line. It is a horizontal line where y is going to equal negative 9. How do I know that? Because look, horizontal lines are always y equals something. And the y in my 2 points I have is negative 9. Now let's look at another one. For this one, I'll call this one point 1 and this one point 2. I'm going to say m is equal to, and I'll start with the negative 10 and negative 12. And then I'll put my subtraction that's in my formula. And I'll go over here and do a negative 1. And a negative 7. Lots of negatives to keep track of in this one. So this is really, since I've got so many negatives, I'll write it again. Negative 12 plus 7, right? And this is really negative 10 plus 1. And what that gives me is a negative 5 over a negative 9, which would be a positive 5/9 slope. Number 4, slope is going to equal. Doesn't matter which point I use, but I'm going to just pick the second point and start with it. I'm going to say y is -5, x is 2. I'll put down subtraction, and then for my second point, I say y is 3, x is 2. So I've got -5 minus 3, -8. And then in the denominator, I've got 2 minus 2, which is 0. And we know we can't divide by 0. So this would be an undefined slope. And that means it's going to be straight up and down. It's going to be vertical. And all vertical lines have the definition x equals something. And I look at my points, and x is 2 in both of them. So this is actually x is equal to 2 is the line. Last one. Slope is equal to, and I'll start over here. I'm going to start with this point this time just because I can. And y is 2, x is 3. I'll subtract, and I have a y of a -5 and an x value of 2. So this is going to be 2 plus 5, and that's going to give me 7. This is 3 minus 1, and that's going to give me 1. And at this point, you guys are all pointing out the fact that I started wrong. And I'm going to start this one over because I got my x's and y's mixed up and just realized it. Okay. I'm going to start with this point as 1, this point as 2. Let's start off by putting the 2 in the numerator and the -5 in the denominator. Subtract. I'm going to do the second point or the first point as it is, and I'll put the y of 3 in the numerator. There's another equation that we think of in the form of y minus y1 is equal to m times x minus x1 called the point slope form. It allows us to find the equation of a line when we know the slope and any one point on that line. The y of point 1, x of point 1 are the points that come from the slope, the coordinates that come, the coordinates that come from the point that we know. So we were going to get it in this format finally, y is equal to mx plus b, which is called the slope-intercept form of the equation. And we know the slope is a -8 for this one, and we know it's going to go through the point 6, 4. So we use our point slope form up here, and we say y minus y in the point that we have, y of 1, and that's going to be a 4, is equal to, and then I have the slope, which is a -8, that's our m, times x, minus, and we use the x coordinate in the point, and that's a 6. So if I do the math and do solve for y, I'll have the actual slope-intercept form of my equation. I'll say y minus 4 is equal to, distribute this, and I have -8x plus 48, and then I just have to add 4 to both sides, and that gives me y equals -8x, and this is 48 plus 4, which is 52. And that's my actual slope-intercept form of the equation. Now, let's do another one. This one, we don't know the slope. We know 2 points. So we have to first find the slope. Let's see if we can do this. We're going to write the 1 point. It doesn't matter where we start. So let's start with y of 19, x of -8. I'm going to subtract the other one, which has a y of -6 and an x of -13. Now let's see what our slope is. This is, of course, 19 plus 6, which is going to give me 25. And this is, of course, -8 plus 13, which is going to give me a positive 5. So I have a slope of 5. M is equal to 5. I'll write that down. And I can use my point slope form now to find with either of these points, doesn't matter which one, and I'll use my slope of 5. So I'll say y minus, and which point do I want to use? Well, maybe the 19 is scaring me and I want to go with this one. So the y coordinate is -6, and that's going to equal my slope of 5 times x minus the x coordinate, which is a negative, isn't it? 13. Well, that's going to turn into x plus 13. And this is going to turn into y plus 6. And I'll distribute 5 times x and 5 times 13. Well, let's see. I'm going to do 5 times 13, and I come up with 65. And then I have to subtract 6 from both sides. When I subtract, I get 65 minus 6, which gives me a positive 59. And there's my equation. Now let's look at the next one. I have a y-intercept of y is equal to 11, and it's going through the point 1, 8. Now, at first, this looks like I don't know enough to do anything, but I do because I know I have a y-intercept of y is equal to 11, and for a y-intercept, x is always equal to 0. So I have my 2 points, and I can calculate my slope. I'll start with this one, and I'll say I have a y value of 8, an x value of 1. I'm going to subtract this one with a y value of 11 and an x value of 0. And I end up with a slope that looks like a -3 over 1, which would be a slope of -3. So I'll write that down. M is equal to -3. Now I can use this point in my point slope form. I'll say y minus the point I have or the point I want to use. It can be either one really, but I'll go with the 1, 8 point. So y minus 8 is equal to a slope of m times x minus, and what was the x coordinate was 1. Let's distribute over on the right. We say -3 times x and -3 times 1, -1. And then this, we're going to have to add 8 to both sides. So 3 plus 8 gives us 11, and there is my equation for my line. Now, in number 3, we're asked to write and graph the slope-intercept form of the equation of a line, but this line is not in slope-intercept form, so we're going to have to solve this equation for y. First, we'll subtract 3x from both sides, and that tells us that 4y is equal to a -3x plus 8. And when we divide everything by 4, we have a -3 over 4 times x plus, and it's 8 divided by 4, which is 2. Now, from this slope-intercept form, I can tell that my slope is -3/4. I can also tell that my y-intercept, which is known as b, is going to be 0, 2. So I can graph it pretty easily from that. I'm first find the y-intercept. It's 0, 2, right here it is. It's always on the y-axis, isn't it? And then I want to use my slope to graph it. So since I've kept the negative in the numerator, this tells me I'm going to go down from this point. I'm going to go down 3, and then I'm going to go in a positive direction for the bottom, or right 4. Remember, it's always rise over run. So this negative tells me to go down, and this positive down here tells me to go to the right. I'll go down from here, 1, 2, 3, and I'll go over 4, 1, 2, 3, 4. There it is. I could keep doing this, 1, 2, 3 down, and 1, 2, 3, 4 over would be the next point on the line. If you ran out of room, you could always reverse it. You could reverse these and go up 3 and to the left 4. Let's see how that looks and see if it stays in line. If I went up 2, 3 up and to the left 4, 1, 2, 3, 4 up, yes, that point really is in line with my equation. So let's see if I can draw a line and graph it. And there's my graphed equation. This example is kind of interesting because it's asking us to graph a linear equation that is a little more difficult to find whole numbers that are actual coordinates. If I wanted to get this into y is equal to mx plus b format, I would add 8x to both sides of this thing. I'll just write it down so you see what I'm doing. And I would also add 6. So I'm going to add 8x over here, and I'm going to add 6. That's going to give me, when I do this, I'm going to have 5y is equal to 8x plus 6. And then I divide everything by 5, and I get a slope of 8 over 5x, which that's not bad. But then plus the y-intercept is not easy to find because it's not a whole number, right? So what can we do? Well, we could plot different points. We could substitute values in for x and find out what y was, and then hope they came up on our graph, and you know how to do that. So I'm not going to do that right now. What I'm going to do is show you how to use your graphing calculator to help you with a problem like this. You want to go to y is equal to so that you can enter this equation, and you want it already solved for y, and it is. And the safest thing to do when you're entering fractions anyway is to put them in parentheses. So I'm going to say this is open paren, and then I'm going to say 8 divided by 5 and close paren, and then I'm going to say x, my x button there, and then I'm going to add, right, I'm going to add, and I have another fraction, so I'll put it in parentheses, 6 divided by 5. I think I got that right. So it's really 8/5 x plus 6/5. Now I want to graph it just to see what it looks like. And there's my graphed line, which I can put a trace on it and find some points on it. It'll put the little cursor on it and it'll say, well, when x is 0, y is 12. But that doesn't tell me too many points. Hopefully, though, you're remembering that you can go to this table feature. I do second and table, and it tells me the coordinates of a lot of different points on this line. So now I can find any number of points that I want to graph. I can say, well, if x is equal to a -4, for example, then y is going to be 5.2. That's not too bad. Here's one that's easy, though. -2, -2, right? -2, -2 would be easy for me to graph. And here's another one. 3, 6 is easy for me to graph. And all I need is really 2 points, and then I can draw my line through those two. You could find any number of points using this, and you wouldn't have to go to the decimals that you're using otherwise. Now, the next part of it is to look and see if we can graph a couple of equations that are specific, special ones. X is equal to and y is equal to a number. And you should always know this, or you should think this. When x is equal to a number, it means that any point on that line has an x coordinate of 6. So here's my x coordinate of 6, and this one also has an x coordinate of 6. In fact, any point that's on this particular line, straight up and down from 6, has an x coordinate of 6. So for x to equal 6, I'm really just saying I have a straight up and down vertical line, right? So if I have x is equal to 6, it's a vertical line. What about y is equal to? Well, it's the same thing. This is a point where y is -2, and this is a point where y is -2, and so on, all across this horizontal line this time. So y is equal to 2, or -2, is going to be a horizontal line. Can you remember the slopes that go along with these? This one is a slope of 0, and the vertical line has an undefined slope. Now let's talk just a little bit more about these slopes and how they relate to each other, especially when we're talking about two linear equations together. If I have lines that never touch, that never meet, they're called parallel lines. They have an equal distance between the lines at all points. If I have parallel lines, I have the slopes are both the same. What about the other situation where I have lines that meet at a right angle? So if this was a right angle where they actually crossed, then what I've got is called perpendicular lines. The slopes of these lines are negative reciprocals of each other. I can use this to kind of to write my slopes. I can use this to write my linear equations as long as I know one slope of one line. Let's take an example. I have a line over here that has a linear equation. It's y is equal to 3x. Now for this particular line, the slope is equal to 3. So, and it's the origin is 0, 0. That's where it's the y-intercept is 0, 0, which is why it doesn't say plus 0 out here. But a slope of 3 tells me this is my line, and this is a parallel line. So what do I know about that line? Well, I know that it has the same slope. The slope for this line is also 3. They've also given me a point on that line, 2, negative 3. Now, with one point and the slope, I can find the equation for that line, which is what I've been asked to write. So I go and use my format. I say y minus the negative 3, y coordinate, is equal to a slope of 3 times x minus the 2, which is the coordinate for the x of the x coordinate of the point. Now let's do the math. We'll say this turns into y plus 3, and I'll distribute, and I get 3x minus 6. And let's subtract 3 from both sides. And that gives me minus 9. So what is the slope-intercept form would be y is equal to 3x minus 9 for that particular line. Let's do these 3 problems just to work with coming up with the point-slope form, or using the point-slope form to come up with a linear equation using what we know about certain lines and points that they give us. This one tells us they want the equation of a line that passes through the point 3, 4, and they want it to be a line that is perpendicular to the line whose equation is y equals 1/2 x plus 4. For this particular line, we know the slope is 1/2. If we want the perpendicular slope that is perpendicular to that, we have to take the negative reciprocal. So we turn this over and turn it into 2, and we change it from positive to negative. So the line that we want has a slope of negative 2. So I've got a slope of negative 2 and the point 3, negative 4. All I have to do now is say I want to use this in my equation. I'll say the negative 4 y coordinate, and I say negative 2 times x minus the 3, which is the x coordinate. And I'll clean up the math here. That turns into y plus 4. This is negative 2 times x, negative 2 times negative 3, and I'll subtract 4 from both sides. And 6 minus 4 is, of course, would give us a positive 2. So there should be my linear equation for this particular point and slope. What else did they give us for B? I'm passing through this point. I'm parallel this time to the line whose equation is 3x minus 8y minus 7 is equal to 0. Well, I can't tell what the slope is on that one. I'm going to have to solve the equation for y. So first of all, I'm going to be subtracting 3x and adding 7 to both sides, okay? I go ahead and write it down. I know I'll have a negative 8y left. When I subtract 3x from both sides, I have 0 minus 3x. When I add 7, I have plus 7. Now I can divide everything by a negative 8. Well, this is going to give me a positive 3/8 x, and it's going to be a negative 7/8. It's going to be my intercept. Okay, so I have my slope. My slope is 3/8. My slope for this line is 3/8. I want a parallel slope, so I really want the same slope. So I'm going to use a slope of 3/8. I'll go ahead and put it into the equation. I'll say y minus the y coordinate of 2 is equal to 3/8 times x, and I'll say x minus the x coordinate of negative 3. Now, all I have to do with this is clean it up a bit. This needs to be x plus 3, doesn't it? And then I can distribute that. Multiplication. I say 3x times 8. 3/8 times x, rather. And then I say 3 times 3 is going to give me... And this is really, if you're having trouble with fractions, this is really 3/8 times 3 over 1, isn't it? So I multiply 3 times 3, and I get 9. I multiply 8 times 1, and I have 8. So there's my y-intercept out there, or part of it anyway. I've still got to finish it up. I'm going to add 2 to both sides. So I say y is equal to 3/8 x. And then I'm going to be adding 2 over here. And I need to add it in eighths, don't I? So how many eighths is that? Well, 2 would be 16/8. So I'm going to do it in eighths so that I can reduce it. What I'm going to be saying is this is going to be 25/8, isn't it? And then I will go ahead and finish that up because I can put it down as 25/8. And as I do that, I look to see, can I reduce that? Well, 25 is 5 and 5, but 8 doesn't have 5 as a factor, so I'm not going to be able to do much more with it, and that will be my equation. So let's do another one that is perpendicular to a line. Once again, we're going to have to solve for y. So I'm going to be subtracting x over here. I'm going to be adding 5. I'm going to have a negative 4y. And when I subtracted x over here, I had to subtract it, and I had to add 5. If you need more steps to see it than that, then you write it down carefully and make sure you don't make mistakes. But by this time, you probably are getting to where you can shortcut this a little bit. I'm going to divide everything by negative 4. And when I do, I end up with a positive 1/4x. And I end up with a y-intercept of 5 divided by 4. So what is my slope for this line? It's 1/4. My perpendicular slope has to be negative since this one's positive, and I flip it around and say 4/1, which is 4. So what slope do I want? I want a slope of negative 4. Therefore, y minus the y-coordinate of negative 1 would equal the slope of negative 4 times x minus the x-coordinate, which is 1. This is really y plus 1, and it's equal to negative 4x plus 4. And then I just need to get this 1 to be subtracted from both sides. So I say negative 4x, and I say 4 minus 1 is 3, plus 3. And that's my linear equation.